Using Metcal Calibration Management Software with a 96270A RF reference source can dramatically shorten the time it takes to calibrate a spectrum analyzer. This time-compressed video was edited from a full Agilent E4440A calibration using a Fluke Metcal procedure and the Fluke 96270A 27 GHz low phase noise reference source. The full calibration procedure takes about 1 hour and 10 minutes with minimal connection changes and minimal operator interaction. This is about 12 hours faster than the same calibration done manually and about twice as fast as the manufacturer's own calibration system. We are including a timer so you can see how long it takes to run this procedure. The equipment used in this calibration includes a fully optioned Fluke 96270A RF reference source, an Anritsu MG3496C signal generator, an Agilent 11667A and an additional 11667B power splitter, attenuators and various connectors on 4 low-pass filters. Details on these required accessories are included with the procedure. So sit back, grab your popcorn, and get ready to see the fastest way to improve your lab's efficiency in spectrum analyzer calibration. Today we're going to be using Metcal runtime to calibrate an Agilent E4440A PSA series spectrum analyzer using Metcal to control primarily the 96270A RF reference source and some other pieces of equipment as well to perform performance verification on this unit under test. So I've already selected our unit under test asset in Metcal and the procedure that we're going to be running today as well. So Metcal's already configured and ready to run. I'm going to go and switch to the Run tab, click the Run button, and we're going to start running our procedure. So all the procedure files are loading now. This is the first dialog that you'll be presented with, which gives you the option to choose which tests you want to perform out of all of the tests that are available in this procedure. Unchecking this box will update your estimated runtime here as well. If you need to know any more information about any test, just click on it to select it, and details will be presented down here in the bottom about what that test needs in order to be completed. So today we're going to be running all of the tests, so I'm going to press this Select All button here, which checks all of these boxes for us, and we're going to press OK and proceed to the next step. So this is a listing of all of the pieces of equipment that are required for this Metcal procedure to run. As you can see, the Fluke 96270A is the star of the show. It's fully equipped with all of the options and also some additional equipment to go with it for some of the tests that where it is required. So we have all of that. It's all present, it's all configured, it's also all connected to the GPIB interface already. So I'm going to go ahead and press OK. Metcal is going to go out and make sure everything is there and that we have the right equipment hooked up to perform the tests. And now we're actually into the Metcal procedure body itself. This is a gold procedure that's available on our Met Support Gold website for subscribers to that plan. So you can download this at any time by going to flukecal.com. And once you get into the procedure here, you'll see there's some copyright information. I'm going to press Advance to go past that. And Metcal is now instructing us to connect our unit under test to the GPIB interface as well, on port 1 in this case. I'm going to press Advance. Metcal is going to go out, find the unit, query it to determine that it is the correct model number to go with this procedure, so that makes sure that we don't run the wrong procedure on the wrong unit under test. It's also going to obtain information about the serial number and firmware revision that's installed on this unit, because some of that does affect the various tests that are performed or the tolerances of those tests throughout the procedure. So we validated that everything is correct here. I'm going to go ahead and press Advance. Metcal will go out and also query the unit to find out remotely what options are installed. So again, it can adjust itself and perform the correct test points. This procedure is also configured to use a flexible microwave signal generator. Today we're using the Anritsu MG3694C. That generator must meet a minimum set of requirements, and that is what's listed on screen here. It has to meet all of these requirements, and Metcal is asking us to confirm that it does. It does, so I'm going to press yes. You can also, if you choose, you can review the list of required accessories and adapters that are required for this procedure to run. We have all of those present today, so I'm going to skip that and answer no, I don't want to see that list of details, but if you choose to see a more detailed list, press yes here. I'm going to hit no, and we've got another test decision to make here, asking if we want to review connector information for the variety of different connectors that will be used for this procedure. If you would like to review that information, press yes, and that will walk you through safety precautions and good practices for making those connections and also tightening them to their correct torque specs. But we're going to press no because we already know all of that information. And the next prompt is asking if we want the procedure to pause on failed tests. For the purposes of this demonstration, I am going to go ahead and say no here because we don't want the test to get or the demonstration to get interrupted because this unit under test is expected to fail the absolute amplitude accuracy. And we'll show you what test failures look like in Metcal with that information as well. So I'm going to press no here, so it will continue past those failed tests. And the next prompt is talking about options in the UT, which options are covered by this procedure and which ones are not. So that information will be available to you when you run it in your own lab. And last piece of test information is a notification about warm-up time requirements for this test. The UT requires a 2-hour minimum warm-up time, which we have satisfied. So we're going to press advanced here as well. And Metcal now is in control, remote control of the unit under test, and it is performing an internal alignment, which you can see here in the top status bar area of Metcal runtime. It shows that we're performing an internal alignment and that the system alignments align all now operation is in progress. So that just takes a minute or so to complete. It's just basically a self-calibration. And once that's finished, we'll begin testing. All right, so internal alignment's complete and it passed. You can see the indication down here in our results grid behind that prompt. Internal alignment with a passing indicator, the screen check box off to the side. So that one is finished, and we're now moving on to the frequency reference accuracy test, testing the internal oscillator on our PSA spectrum analyzer, which is our unit under test. So our connection instruction here has us connect the UT on the rear panel of the UT, the 10 megahertz reference output, to the 96270's frequency counter input. The 96270 does include a frequency counter mode and functionality, so we'll be using that for this test. That connection is already in place, so I'm going to press advance. The next instruction here is in asking us to connect our 10 megahertz house reference, which in this case is a WaveTech 909, 10 megahertz frequency reference to the reference frequency input of the 96270. That's going to allow our 96270 to lock itself to that external, more accurate 10 megahertz reference, which is required for this test. So that's already in place as well. I'm going to go ahead and press advance. The 96270 is now making frequency measurements using its frequency counter function, and you can see that test is already finished, and we have a passing result. I have to talk very quickly because some of these tests go by very fast. Those are already completed, and now we are moving on to power bandwidth accuracy, which does not use any external standards. As you can see, we have nothing connected to our UT RF input at this time, so we've already followed this instruction here, which is to disconnect everything from that input. I'm going to go ahead and press advance, and you will see the power bandwidth accuracy test in progress. As that test is running, each of the test points that it's testing, you'll see some status information here in the Metcal header as well. On the second line down, you can see that we're testing a resolution bandwidth setting of 1 Hertz. And Metcal will update all of the required settings as it finishes each test point. You can see we've already finished the 3 Hertz test and the 10 Hertz test. And Metcal will continue testing the rest of the points as required for this power bandwidth accuracy test. When it's finished with this test, it will also move on to the next test, and it will continue doing that until there's an operator intervention is required. Perhaps another connection change will be needed, at which point Metcal will pause and give us instructions on how to make the next connection and wait for us to press advance once that connection is in place. Okay, that test is finished, and Metcal is now moving on to the resolution bandwidth switching uncertainty test, which you can see is going fairly quickly. We have this the circle indicator here showing progress of each of the steps in that point. Those were moving by pretty quickly. You can also see down on the bottom of Metcal runtime now we have an overall progress indicator, which is showing the progress of all of our tests throughout the entire procedure. So you can see we're about maybe a fourth of the way into this procedure already. We have finished the last test and we're now moving on to residual responses. Metcal is asking us to connect a type N 50 ohm termination to the input of the UT. So I'm going to reach across here and make that connection. Again, following good connector precautions, holding the body of the connector still while rotating the collar so we don't have any rotation or anything on our center conductors causing wear or damage over time. And that information is part of what was available earlier in the connector precaution information if we chose to view it. That's the type of information you would find there. So that connection's in place. So I'm going to go ahead and press advance. And Metcal is going to proceed with the residual responses test followed by the displayed average noise level test, both of which use the same 50 ohm termination as the required connection. And both of these tests are somewhat slow and take quite a while to run. So there's probably going to be about 25-minute or 30 minutes worth of testing with this connection in place. And this would be probably a good time to fast forward through this if you don't want to sit and watch all of the noise tests being performed. About 25 or 30 minutes worth. And Metcal will control all of them completely unattended. All right, so the displayed average noise level test is now finished and we are being prompted for the next connection message, which is to connect the 96270's leveling head directly to the UT-RF input, and also to connect the 96270's 10 megahertz reference frequency output on the rear panel to the UT's 10 megahertz reference in, so that we can establish a phase lock between the two units for the tests where that is needed. So I'm going to reach across here, remove the termination, connect the leveling head directly to the RF input. Again, holding the body of the leveling head still while rotating the collar. And once I have that finger tight, I will finish it off with the torque wrench to make sure that we have that connection torqued properly. And we are now ready to proceed with this test. So I'm going to click on advance, and this will cause Metcal to begin taking measurements for the frequency readout accuracy test. Once this test is finished, it will then move on to all of the other tests in sequence that use the same connection. It'll get through as many of those as it can before pausing and prompting for the next connection change. The frequency readout accuracy has already finished, and we're now moving on to frequency span accuracy. Metcal makes pretty fast work of these tests, combined with the 96270's capabilities. So that test is also finished. Metcal is now moving on to the count accuracy test. One thing I forgot to point out here in the header is that as Metcal controls the 96270 from test to test, which is now finished with that one and moved on to noise sidebands, but you'll see as it controls the 96270 to source various signals, you'll see information here presented about the stimulus that Metcal has asked the 96270 to deliver. And that holds true for all instrument FSCs in Metcal, which an FSC stands for Function Select Code. It's basically Metcal's version of a driver that does instrument control and many other duties as well. And you'll see that these stimulus messages are generated automatically by Metcal for devices that are controlled by an instrument FSC. I usually like to focus on the second line down, though. That's the one that usually gives you pretty regular updates about which test points are being tested currently. Okay, looks like the noise sidebands test is finished. Now moving on to absolute amplitude accuracy, which this is the test that I mentioned earlier that we expected to find some limit failures on. As you can see, our status indicator in the left column there has switched from a green check mark over to a red X. In this particular runtime, Metcal is not pausing on a failed test because I instructed it not to at the beginning of this procedure. The procedure actually asks if you want it to pause on failed tests or not. If you say yes to that prompt, what will happen is on that very first test failure, Metcal will generate a prompt, give you additional information about the test that failed, what the reading was, some information about the error that it encountered, the test error, limit error that it encountered, and it will allow you to choose to repeat or cancel that test or terminate the entire procedure or just advance past it. You get several different options actually. But for the purposes of this demonstration, we just said we did not want to pause on that failed test condition. So we're now getting prompted by Metcal to insert a 10 dB attenuator between the leveling head and the UT RF input. So I'm going to reach across and do that now. Just inserting a 10 dB type in attenuator between the leveling head and the RF input. Metcal has already recorded a reference reading before inserting this attenuator, and it is now going to re-level the output of the 96270 back to establish that previous reference, but now with the 10 dB attenuator in place. So we always maintain that continuity from before and after inserting or changing out one of these attenuators. That connection is now in place. I'm going to go ahead and press advance. And while the procedure is running, I'll talk a little bit about why we do that. In the case of the PSA series spectrum analyzer, they really are quite good spectrum analyzers with very tight specifications on many of the tests. In order to achieve suitable test uncertainty ratios for those tests, we often have to insert various devices like an attenuator in order to keep the 96270 in its prime operating range, or in where I like to call the sweet spot. And by inserting those attenuators and re-referencing re-leveling the output back to the original reference value, we've now increased the output level of the 96270 to the point where we can keep it in that sweet spot and maintain those good test uncertainty ratios. Not all spectrum analyzer workload will have that requirement. If you don't have a spectrum analyzer with the same level of capabilities or the same types of specifications that the PSA series has, you may be able to do without any external attenuators and those other sorts of techniques at all. But in the case of the PSA, it really is a quite good spectrum analyzer, and those devices are required for the performance verification. In fact, you'll see in just a moment, Metcal is going to pause and request that I swap that 10 dB attenuator out for a 20 dB attenuator. I believe that happens later in this display scale fidelity test. So for now, it's proceeding with the absolute amplitude accuracy test, and it will pause whenever it needs us to swap out those attenuators. So you see a third indicator on that left status column now too, which I don't think we've seen yet. If we did, I may have missed it earlier. You see it's a yellow check mark. What that indicates is a marginal result, a passing but marginal result. And as defined by this procedure, that means that our reading that we took for that point was greater than 70% of the allowable tolerance, but less than 100% of the allowable tolerance. So that means it's getting close to the tolerance. You may or may not want to do something about it. That's meant to just kind of draw your attention to the fact that that reading is maybe approaching a failed status. But as you can see, now we moved on to the input attenuation switching uncertainty test, and we're back to passing readings again. I just wanted to point out that other marginal status indicator and what that meant. There are two other types of indicators you may see in Metcal procedures, depending on whether or not you have guard banding enabled or not. If you do have guard banding enabled and you encounter a pass indeterminate or a fail indeterminate condition, Metcal has a different indicator for those. It'll be a green check mark like what you see on screen now with a question mark next to it, so it's more of an oval shape instead of a circle icon. And a fail indeterminate is similar, but it's a red X with a question mark instead of just a red X with a circle icon. Okay, we are now to the next connection message, which is part of the display scale fidelity test. Metcal's asking me to remove the 10 dB attenuator and insert the 20 dB attenuator in its place. Again, we are just trying to keep the output level of the 96270 in its prime operating range, also known as the sweet spot. And by inserting this attenuator and re-establishing our previously recorded reference, we are able to continue with this test while keeping the output level of the 96270 high enough that we stay in that prime operating range. Okay, that connection is now in place, and you'll notice that we kept the 10 megahertz phase lock connection in place in the back of these instruments throughout the duration of the procedure. You can leave that connection in place the whole time. Metcal will control the PSA to switch it onto using that external reference when it needs it, and then also ignoring it when it doesn't. So you can just leave that connection in place the entire time. All right, we're ready to proceed, so I'm going to click Advance, and Metcal will continue on with the display scale fidelity test. So there's a couple progress indicators that show what's going on here. On the Metcal side, you have the header information, which I referenced earlier, showing both some information here on the second line about what test is in progress, also some information about the stimulus as it changes when Metcal requests different signals from the 96270. You also have the progress wheel indicator down here on the bottom left, which is showing your individual step progress for the test that's going on currently. So you can see that wheel kind of circling around as each one of the tests is completed. And then you have the overall progress indicator down on the bottom again, which we're up at about the halfway finished point or so on this procedure, maybe just a little bit farther. So those are just some of the indicators that Metcal gives you that progress is being made. Plus you also have all of your data on screen here in the data grid, which you can scroll back and look at if you need to, using the scroll bar over here. And then at the end of this procedure, we also will have the option to export the results using this icon here, which will export everything that you see on screen to a CSV file. It is worth noting that that will not give you the full results data that will be available in MetTeam. That will still be stored in MetTeam, of course. That export button only gives you what's visible on the screen at the time for convenience. Okay, the next connection instruction is in place. It's just asking us to remove that 20 dB attenuator that we inserted earlier and reconnect the leveling head directly to the RF input. I'm going to torque that right back down using the torque wrench that's included in the 96270 kit. And we are now ready to proceed with the second harmonic distortion test. So I just clicked Advance, and Metcal will continue making measurements. Okay, we're still in the second harmonic distortion test. Metcal is asking us to insert two 1.8 gigahertz low-pass filters between the leveling head and the UT RF input. So I am inserting those low-pass filters now. And those are in place, and I am going to click Advance and let Metcal proceed with this measurement. That one's over very quickly. And then now Metcal is asking us to remove the low-pass filters from the test setup. Now I'm going to click Advance so that you can see the next connection instruction while I'm removing this. And I'm going to talk to that connection instruction just for a minute here. That is asking us to insert the 9600 FLT 1 gigahertz wide offset phase noise filter, which, as you can see on screen there, it's suggested to mount to the side of your 96270, and that serves as a filter for the 1 gigahertz source signal that the 96270 is going to provide. But in this case, I'm actually going to leave that filter out because I know that my 96270 that I'm using has sufficient performance to go with my UT, which has sufficient performance as well, to actually allow this test to pass without the need for inserting that filter. So I'm going to leave the filter out, but just know for some workload or for some particular UTs, that filter may be required. That filter is available if you should need it. But in this case, just based on experience with this particular hardware, I know that it'll pass without it. So I'm leaving it out, and I'm going to click Advance. And I've already put this connection in place, which is the leveling head, directly to the UT RF input. And I'm going to click Advance here as well. and we should see passing results coming up next. Even without that 9600 FLT wide offset phase noise, affectionately known as the WOPN filter, WOPN, you'll see that it should still pass these tests even without that filter in place. Pretty good testament to the cleanliness of the 96270 signal. So as promised, we are getting passing results for these tests. Even without the 9600 FLT filter in place. All right, so Metcal's now prompting us to remove the leveling head connection to the 9600 FLT, which we don't have in place, so I'm going to press advance. And now we're having a connection instruction for the frequency response test, which asks us to connect the leveling head directly to the UTRF input. That is already in place from before, so I'm going to go ahead and click advance. And Metcal will proceed with the frequency response test up until the point where it needs the next connection change, which will be the first connection change where we replace the leveling head and begin to use the microwave output with a power splitter and sensors. Now, the thing to know about the power splitter is for the PSA series spectrum analyzer's frequency response test between 300 kilohertz and 3 gigahertz, it requires a characterized power splitter with very good mismatch characteristics. For that reason, we are using an 11667A power splitter for this test, which is not included with the 96270 kit, for its better VSWR characteristics. We have already characterized that power splitter using the 96270 and stored that characterization data in the profile memory within the 96270. And what you're going to see happen here in just a few moments is Metcal will go out and ask the 96270 if profile data already exists or not, and it's going to present us with some details about that profile so that we have the information that we need in order to determine if we want to reuse that existing profile or not. In this case, I've already measured the profile. I've already had the power splitter data characterized as needed, so we're going to use that profile that's already stored in the 96270. One thing we do recommend that you do in order to keep that your connections straight and make sure that your connections, like in this case, now that we're doing the performance verification, match our characterization data that we stored previously, we actually recommend that you label your power splitter output ports, either A and B or 1 and 2 or Bob and Larry or whatever you want to label them, just some kind of convention that makes sense to use so that you know which of those ports was characterized as your reference plane during the profile measurement. You always need to know which reference plane you're using and which reference sensor was connected to that port, so that you can connect your leveling sensor to the other port and keep your data aligned correctly with the connections that you're making and not reverse your port tracking data that you've stored in your characterization or in your profile, sorry. So that's just a good tip. Label your power sensor or your power splitter output port so that you can always keep those straight. It is important to know which sensor was used on which output port during the characterization, and then also make sure that the right sensor is connected to the correct port during use as well. You do not want to reverse those. Okay, Metcal is beeping to get our attention because it is asking us for some information now. Wants us to make a decision about whether or not we want to use that profile that I mentioned earlier that was recorded previously. So as you can see, there's quite a bit of information on screen here. The date and time for when that power splitter characterization was performed, the type of splitter, the output that was established, the reference plane, which all correspond to the different modes in the 96270. the sensor, it's one that was used and which serial number it was, and so on. So this is all meant to allow you to make an educated decision about whether or not you want to use that profile data. Perhaps somebody else recorded that profile with some different power sensor serial numbers than what you have available, in which case you would say, no, you don't want to reuse it. And Metcal would walk you through the steps to create a new profile and characterize your splitter with new data. But in this case, we already have that characterization data in place. So Metcal is asking us, do you want to use this existing profile? And I am going to say yes, because I know that's the one I want to use. And we're now going to get a new connection diagram, which has us remove the leveling head from the test setup. That's actually the last time the leveling head will be used for this procedure, so I'm going to set it aside over here. And I'm going to bring our characterized power splitter in, which is already pre-configured with all of the adapters that we're going to need. And I'm going to connect that to the UT RF input, only with an adapter. Notice there's no cable there. That is actually important. The Metcal procedure reminds you of that as well. You don't want to use a cable there necessarily because of the potential for loss. You want to keep the connections as direct as possible. So I have the original leveling sensor that we used during the characterization connected to the same output port of the splitter that was connected to during characterization. And I have the other port, which is our reference plane that we established, connected directly to the UT RF input as possible. I'm torquing all of these connections, and we are now ready to proceed. So our connection's in place, and I'm going to press advance, and Metcal will continue with the frequency response tests up to 3 gigahertz using this test setup. And above 3 gigahertz, the specifications on the E4440A spectrum analyzer actually widen quite a bit. So we can switch to our 1167B power splitter that's included with the 96270 and use it for the remainder of the frequency response tests up to 26.5 gigahertz. And that's also used for some other tests after frequency response as well. Again, up to 26.5 gigahertz. So the critical characterized power splitter is only used up to 3 gigahertz for this particular UT. And again, that's just to establish acceptable test uncertainty ratios. So Metcal has instructed the 96270 to use that profile. And we're leveling it with the same sensor that was used when the profile was stored with our characterization data. So all we've done essentially after characterizing the power splitter is remove the reference sensor from the output port and connect that same output port directly to the UT RF input. That characterization process is actually quite fast also, but for the sake of brevity, we skipped it for this demonstration and used the profile data that exists previously. Okay, Metcal is now finished with that power splitter. It's telling us to go ahead and disconnect it. And it's going to have us connect our 11667B power splitter in its place for this next connection instruction. So as you can see, there are some pictorial diagrams on screen to help facilitate the ease of connection here. So hopefully those connection instructions are fairly clear. Once you download and run this procedure, which is available on the flukecal.com website. So again, I'm going to torque these connections here, make sure everything is mated up properly. including our adapter we added here. And our connection is now in place, and we're ready to proceed by clicking Advance. And Metcal will now continue with the frequency response tests above 3 gigahertz. And then I believe it moves on to spurious responses after this. So this connection will be in place for some time. All right, looks like frequency response is finished, and Metcal's now moving on to the spurious responses test. Still using the same setup, so no connection change required. The good thing about these long periods of walkaway time is instead of sitting and watching it, perhaps you could go enjoy a nice hot cup of coffee or maybe even calibrate another piece of equipment. Have multiple Metcal workstations running at the same time. All right, spurious responses test is finished, and we're now moving on to second harmonic distortion. You'll see here in just a minute I should get a prompt to insert a pair of 4.4 gigahertz low-pass filters. And here comes that prompt. I hear it beeping. All right, Metcal's calling for me to insert two 4.4 gigahertz low-pass filters between the microwave output and the power splitter input port. So we are connecting those right now. Torquing as always, although it's not quite as critical since we're still going to be leveling our delivered power by a power sensor. Always want to follow good practices. And that connection's in place. I'll go ahead and click Advance. And that one's over fairly quickly. But now we have quite a bit more involved set up in place. This is for the last test of our procedure, the third order intercept test, and we're going to be using the 96270 along with a second microwave generator and combining those two signals into the RF input of the UT. So I am going to almost completely disassemble this test setup here and replace it with the one that we need to support third order intercept. So this connection change will take me just a moment, and then we will continue. That connection diagram on screen reflects what I just put in place in front of the unit. Some other instructions may include the use of directional couplers or other devices. We have found that using a power splitter provides even better performance as long as you have sufficient isolation between the generators. 10 dB pads will typically provide sufficient isolation. So that is the recommended test setup for this test, and that's now in place. We also added another 10 megahertz connection on the rear panel of these instruments to extend that 10 megahertz phase lock connection over to our Anritsu MG3694C generator as well, so that all three devices are phase locked together. And that is all in place, and I'm going to press Advance, and Metcal is going to continue along with this test, taking more measurements, and this will be the final test of our procedure. As you can see, we're getting passing results on the TOI test. And remember that if you don't have your second microwave generator available when you need to do this performance verification, maybe it's out in an on-site or otherwise in use, you can always uncheck that TOI box at the very beginning of this procedure, and Metcal will omit this test from the run, and also it will not look for that Anritsu generator on the GPIB interface. So you won't get any messages about it not being present when it needs to be present if you uncheck that box in the beginning. Once that generator becomes available again, you can go back run this procedure again, clear all of the other selections and select only the TOI test, and then Metcal will then just perform that one test and none of the others. So you can then consolidate your test results in MetTeam. It's very easy to do. MetTeam will allow you to identify even whether or not all of the required tests have been performed, and you can make sure then that TOI test is not forgotten and that someone has to come along and complete all the required tests in order to generate a certificate before allowing that certificate to be produced in MetTeam. So a very nice feature and very tight integration between software, runtime, and MetTeam. All right, and that is the end of the procedure. I'm going to click OK here. This is the standard Metcal prompt to remove all connections. And what you'll see next is that the MetTeam work order will come up. That will give the technician the chance to fill in any additional information that's required, perhaps ambient temperature and humidity conditions. They can generate their certificate, they can generate their labels, they can make any adjustments that they need to status throughout your lab's workflow. And once they're finished, they can close this work order, and this procedure is complete. The data has been stored in MetTeam, and your certificate's ready to generate. You've just seen how using Metcal software with the 96270A 27 GHz low phase noise reference source can dramatically reduce the time required to calibrate a spectrum analyzer. The fastest way to improve your lab's efficiency in spectrum analyzer calibrations. For more information about Metcal software or the 96270A, visit www.flukecal.com.